This video will cover Trig Notes 6.3. The topic for this video is ellipses. So we're continuing graphing conics. Specifically for this one, it's going to be ellipses. So here's a diagram of what an ellipse will look like. You'll notice it's very close to what a circle is, but it's going to be elongated in one direction. It's either going to be elongated horizontally, like this one, or it could be elongated vertically, and that would look more like this. So whichever way it's elongated, so for this example, this diagram, if it's elongated horizontally, that's the major axis. So the longer axis is the major axis. The minor axis would be the shorter of the two. There's going to be some key features on the major axis. You're going to notice that A and C will always be on the major axis. So we need to talk about what A and C are. A is the distance from center to vertex on the major axis. So for this one happens to have a center point right at 0, 0. So this is our center. And the distance from the center all the way to the edge of the ellipse on the major axis, which would be this distance here, that's A. So this distance is A. And at the end, we call these points the vertex. So you actually will have two vertices on your major axis. We could also describe this distance here as A. I'm not going to draw that on the diagram because that can get kind of confusing. The distance from from center to the vertex is A. We also have something called covertices, or a covertex. So your covertex is the distance from center up to the edge on your minor axis. So this distance right here is your B value. Distance from center to edge of ellipse on the minor axis is the B value. And again, that's this distance here. So we have our A values, we have our B values. Let's talk about our C values. C is the distance from center to focus. So in this diagram here, from center to focus would be this distance right here. So that is the distance for C. So you've got A, you've got B, and you've got C. And again, the key focus here is that on this major axis will always lie A and C. So A and C will always be on the major axis. So when we go through to actually create our ellipse, what we need to do is figure out the center and figure out what our distance for A and B are. And once we know what our A and B's are, we can plot our vertices and our covertices, and then we can connect the dots to make our ellipse from there. Let's look at now some formulas for graphing an ellipse. Okay, so looking here, we're going to be talking about when we have an elongated ellipse horizontally, like this diagram is, and when we have an elongated ellipse vertically, like this diagram. Okay, so there's it's really two different sections here. So when we have it elongated horizontally, we said that the major axis is the horizontal axis. Here would be the formula for finding the equation for the ellipse, or in order to graph it. We would need to know certain things. We need to know what A is, we need to know what B is, and we need to know what our HK is. HK being the center, A being the distance from center to vertex, and B being the distance from center to covertices. It's important that you understand, if it's elongated horizontally, that the A value is underneath then the X value here. And the B value is underneath the Y value, or the Y axis, because that's the shorter one. On the other hand, when we talk about it being elongated vertically, A is on the major axis now, which is the vertical axis, which is the Y. So the A value is underneath the Y because the A is the longer piece. Okay, so it's important, the placement of A and B. The only way that these two formulas are different is where A is and where B is. So here A is under the X value because it's elongated horizontally, which is the X axis. Here A is underneath the Y because it's elongated vertically, which is the y-axis. And it's important to also know that the ellipse will always have A being the larger of the two numbers. So if you find A and B, whichever one is the larger one will be the A value. Last thing I want to talk about is, you notice that these equations don't have a B in them, excuse me, a C in them, but we talked about C being the distance from center to focus. There's a relationship that we're going to use to help us find either A or B or C if we're missing one of the three. The relationship is C squared equals A squared minus B squared. So again, if you know, for example, C and A, you're given information about that, you can use it to find B. Again, the things that you need to be able to graph or to write the equation, you're always going to need to know your HK. You're always going to need to know your A value and your B value. Once you know those three pieces of information, then you can plug them into either one of your equations to write the equation or to graph. Okay, so looking at an example here, I'm trying to graph the ellipse that has x squared over 16 plus y squared over 25 equals 1. And I know that we just talked about with an ellipse that the A value has to be the bigger of the two denominators. So in this case, 25 is what A squared is, and B squared would be what 16 is. So my equation really looks like this. It's the x minus the h quantity squared over the b squared plus the y minus the k value squared over the a squared is equal to 1. So when that's the case, when your a value is underneath the y, that means that it's elongated vertically. So if I'm going to try to graph this, the things that I need to pull out of my diagram or pull out of my equation would be what the center is, what the A value is, and what the B value is. So I know that the center is the HK, and notice that for mine I have nothing that I'm subtracting from X, I have nothing I'm subtracting from Y. So this would be a center at 0, 0. So let's go ahead and plot that point first. A value would be if A squared is 25, then to find A, we would take the square root of both of those to find A to be 5. For B squared, if B squared is 16, we would take the square root of both of those, and we would get 4. So that means, since it's elongated vertically, that A is going to be going up and down, and B is going to be going right and left. So let's go up 5, put a dot there, put a V next to that because that is a vertice. Let's go down 5, put a dot there, that's another vertice. Let's go right and left 4, and those would be my covertices. So we're going to put CVs next to those for covertices. Once you actually have those 4 dots on your graph, you can actually connect those to make your ellipse. Now again, try to make it as smooth of a curve as you can. And you should notice that it is not a circle, it's an elongated circle. Last thing you're going to want to do when you graph it is we put on the A and the B. We actually need to figure out what C is, because you should always put your focus on your graph. So if we're going to figure out what C is, the way we're going to do that is we're going to use the relationship we just talked about, that C squared is equal to A squared minus B squared. I know that A squared was 25, B squared was 16. So when I try to figure out what C is, this would be C squared equals 9. If we take the square root of both of those, we would get C to be 3. And because C and A are on the same axis, okay, in this case A was going up and down, so C will also go up and down because it's elongated vertically. I'll go up 3, put a dot there with an F. I'll go down 3, and I'll put a dot there with an F as well. So my focus points, or foci is the plural of focus, will always be inside of my ellipse when I graph it. When we talked about parabolas, we said that the parabola wrapped around the focus. Well, now the entire graph is around the focus points on your ellipse. Okay, taking a look at our next example. I need to figure out which form this is in But what I noticed right away is that my equation always has to be equal to 1. In either one of the two forms that we talked about, it was always equal to 1. So the way that I'm going to be able to get this equal to 1 is to make this 70 a 1 by dividing through by 70. I need to do that to everything. So that would end up making my problem be 5 goes into 70 14 times. So it'd be x squared over 14. 7 goes into 70 10 times, so it'd be y squared over 10 equals 1. So sometimes we have to do a little bit of work to our equation to get it in the right form. So now I can see that this form is the form where it is the x minus the h quantity squared over the a squared, because a has to be the bigger one, and then plus the y minus k quantity squared over the b squared equals 1. So because a is underneath the x value, this is elongated horizontally. So if it's elongated horizontally, that's important for us to know that our a is going to be going left and right, so will our c values. So we need to know our center, we need to know our a, our b, and really our c, although to graph it we don't need to know b. We just want to put, or c, we just want to put that on the graph. So our c again here, our hk here, let's talk about that first, is there is no values for those, so it's going to be 0, 0. We'll eventually move off of the center being at 0, 0. Our a value, since a squared is 14, the square root of a squared is approximately 3.7 when I take the square root of that. I need to figure it out as a decimal so I know how many up and over to go on my graph. In this case, a is elongated horizontally, so it's going to be left and right. I'm going to go 3.7. So 1, 2, 3, 4, 1, 2, 3, 4. 2, 3, 4, 5, 1, 2, 3, 4, 5. So A we went over 3.7. 1, 2, 3.7 is right about there. That is a vertex. 1, 2, 3.7. That is a vertex. Let's figure out what B is. B squared is the square root of 10. And that as a decimal is 3.2. So we're going to go up and down 3.2. Up 3.2, that's a covertex, down 3.2, that is a covertex. So when we graph this, we're going to find, fix this side a little bit. It's going to look like that. We want to continue to put our c on there, though. Our c value we would find when we do c squared equals a squared minus b squared. So in this case, our a squared was 14, our b squared was 10. So I'm going to get c squared equal to 4, so I know that c is going to be 2. So because a and c go together, I know that this one is going to be going left and right. So it's got to be on the major axis, which is horizontally. So that's my focus, and that's my focus. Okay, taking a look at the next example, I've already graphed the focus and the vertices on my axis here, so I invite you to pause the video and do the same here, and then play it again so you can pick up the next of my explanations. Once you've graphed it, what you're going to want to do then is recognize that C and A are on the horizontal axis, so that means that this is elongated horizontally. Which means the standard form of the equation will have the A value underneath the X minus the H. And the things that I need to know to be able to graph this, I need to know my center, I need to know my A and my B, actually to write the equation, not to graph it. So my A value is 5. My B value I don't know, but I do know C is equal to 2. So let's plug that into this information here and figure out what C is going to be. So C squared equals A squared minus B squared. We would have 2 squared equals 5 squared minus B squared. and we'll pick it up in the next